All right. When it says varies directly, you need to use this equation, y equals a times x. That means x is being multiplied by a constant, and y varies directly by that. Okay? You may have gotten it a different way, but you're going to have to use these today. So, and then this one here, you could use y equals ax, but basically, distance and rate times time is a direct variation equation. The distance is affected by the time in a constant rate. So you could use either one of these. They work the same way, and that's kind of what I did. I found A first, plugged it in here for the rate, times 5, and I got 260 miles. Actually, this is 3.5 here for x. Plug that in like that. A equals 52, and then I plugged it in because that's really my rate, my constant speed. That was the word they were talking about. Okay, so that's from algebra. So let's talk about the three things. This whole chapter is about rational functions, graphing, seeing how they shift on the graph, and the different forms that you're going to see. That's what this chapter is about, or at least the first 3 sections. I haven't done the last 3 yet. So here you go. These are the 3 equations you're working with. Y equals a times x, that's direct variation. Always, 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 when you're working with these rational functions, you're going to probably have to solve for a. So how would I solve for a in this? What would I do? I would end up having a equals y divided by x, correct? So you want to write that down, because the key component is a. In order to write the equations, you have to have a. Here, inverse variation is when you're dividing by x. You have the constant divided by a variable. And if I had to solve for a for this, what would it look like? A would equal what? Y times x, right? Okay, and a is always going to be that important piece that you need to find out in order to write the equations. Y varies inversely. I have these underlined because you're going to have to look for these key words when you get story problems. Varies directly, varies inversely. Then you know what you're working with here. Okay? This is a new one for me, joint variation. Basically, it's just you have a constant times 2 or more variables. A, again, is your constant. Here, we don't really necessarily need to figure out what it would look like to solve for A, because as of right now, you're not going to do much of that. So if you see Z varies jointly with X and Y, that means it's A times X and Y. Q varies jointly with QRS, that's A times Q times R times S. That's what it means. Okay? So these are just kind of new. These you've seen before. You may not remember, but you have. In order to write any variation equation, you must find A. If it says write the equation, you have to find A. That's what you're doing here, either with this or with this. So, tell whether X and Y show direct variation, inverse variation, or neither. So you got to solve for Y. For any variation here, the y-intercept is 0. Is there a y-intercept on this equation? If you think of it like this, basically it's the same thing. There's no b, is there? No. Same with this. There's no b. So the those particular graphs always go through 0. So here, you've got to just solve for y. So y plus 3x, y equals 3x. Okay, so take a look at that. Which one is it? Direct, inverse, or joint, or neither? It's direct. So that's all you would say. It's direct. Y equals ax. That's direct. Okay? All right, here, let's solve for y. What would you do to start that? Always get rid of what's in the bottom. That's my suggestion. So how would I get rid of that y in the bottom? Multiply both sides by y. And I get, oh, look at that. Y times x equals 3. Or you could write it up like this. Y equals y times x. What form is that? It's inverse. Okay? Inverse variation. So either it's in this form or this form. It doesn't matter. You could rewrite it so it looks like exactly like that form. And that's inverse variation. All right? How about this one? Let's do this one. If I solve for y here, I get this, 5 minus x. If I put it in this form, what's the problem there? It has a what? That has nothing to do with it. Because this would be the same as this, right? What's the problem with it? It has a y-intercept. It has a y-intercept of 5, and we can't have that for direct variation or inverse variation. So this is a neither. So that's the first part of what you're going to have to do is rewrite the equations and recognize if they're this, this, or this. Okay? All right, then you're also going to be given a table. And it's going to say, tell me whether this table represents direct variation, inverse variation, or neither. It doesn't say anything about joint variation in here. You're just trying to recognize if it's inverse or direct. Now, if it's direct, it's going to look like this. Hold on, I've got like so many sheets here. Inverse is this. A equals y divided by x. Looks I have x and y here, don't I? X and y is represented here. Direct, A equals, I'm sorry, I wrote it wrong, didn't I? This is direct. Inverse is A equals y times x. So I'm going to determine whether I get the same A by dividing y and x. If I don't, then it's not direct variation. Or if I get the same A by multiplying y and x. If I get the same A each time by multiplying y and x each time, then I can determine if it's direct or inverse. So let's start with dividing. If I take 40 divided by 1.5, what do I get? I'll tell you what I get. I get 26.7. So that's my first point there. I did 40 divided by 1.5. Let's try again for the next point. 24 divided by 2.5. What do I get? Yeah, and this is not working for me. I have to get the same constant A. So it's not direct variation. Here, if I multiply the x and the y together, look what happens. 1.5 times 40 equals 60. 2.5 times 24 equals what? 60. And if I went all the way across, 4 times 15 equals 60. So you have to get the same constant of variation is what it's called. That's what A is. And so this is happening here, so that means it's inverse. It's an inverse relationship. Make sense? Tell you right here, the variables x and y do what? Vary inversely. So I have to figure out, okay, I'm working with this equation right here. Varies inversely, I'm working with that equation. Stop and identify that right away. So use the given values to write an equation relating x and y. It's the first thing I have to do. And then find y when x is 2. It's kind of like the warm-up you just did. So you got two things. You got to find the inverse equation, and then you got to plug in 2 for x and find out what y would be in that function. So in order to do this, you must find A, just like I wrote on the other side. In order to write an equation, inverse, direct, anything, you got to solve for A. This is so important right here. In order to write any variation equation, you must find A. So, if I'm working with this form, y equals A over x, and I was given x and y, can I find A? Of course. We plug in what we were given and solve for A. Okay, we were given 15 for y. I don't know A. I'm working to find that. And it's divided by 1/3. So let's get rid of that 1/3 by just multiplying both sides by 1/3. Multiply both sides by 1/3. That goes away. A equals 5. Okay, so I still haven't finished my step 1. What's my step 1? I've got to find an equation. So if I know that A is 5, then I write the equation like this. That's part 1. That's the inverse equation. Step 2 says find y when x is 2. So y equals 5 over 2. Basically, there's not much more I could do. I could divide it if I wanted to. But I'm just going to leave it like that. So that's part 2. Okay? Let's try one of those again. It varies inversely, so I'm working with this. I got to find A, so I plug in what I was given. What's A? A is 12. So now I can write my equation. Y equals 12 over x. Y equals 12 over x. That's part 1. And then I just plug in 2 for x. And I get y equals 12 over 2. Y equals 6. There you go. Doable? It gets better. Okay. So, let's do this. Given the sentence, write the equation. R varies directly with x. Okay, so I'm going to have an equation with a bunch of variables. I don't have any numbers. R varies directly with x. So I go back and I say, well, this is a direct variation equation. And it says that R varies directly with x, which means R depends on x, which means my function is going to be R equals some constant times x. What R is depends on x, varies directly with x. That's what that means. Everybody good with that? When it says R varies directly at x, it basically means R depends on x, and it's a direct variation. Got it? X is the food, R is the poop. Okay? All right. Let's do another one. P varies inversely with the cube of Q. So what depends on what? P depends on Q. So it's going to be a P equals, and it's inverse, so it's going to be A over what? Q what? Q cubed. P varies inversely with the cube of Q. P depends on Q. It's inverse. I set it up as an inverse with P equals whatever. Got it? Okay. Z varies jointly, oh, there's a little jointly one, with M and the square root of N. Okay, so Z depends on that stuff. It varies jointly. But I also have to write a what? Not just M and N, but I have to write a what? The constant of variation, which is the letter what? A. Times M times the square root of N. Anytime you have a variation equation, you have to include the constant, the A. Right here, yes. It varies with more than one variable. Okay? Okay, M varies directly with B and inversely with C. Okay, so varies directly is when it looks like this, correct? And inversely is when there's a variable in the denominator. Okay, so we have two things going on here. So, first of all, M depends on this stuff. So I know it's going to be an M equals. Okay? I know I'm going to have an A, no matter if it's inverse or direct variation. Well, it varies directly with B, which means it's going to be A times B, correct? But inversely with C, so where would C go, do you think, in the bottom? So here's the first part of the condition. It varies inversely with B, varies directly with B, and inversely with C. So it meets both conditions. Yeah? That's just language, just learning the language. Okay. Oh, look, a story problem, of course. Moving cartons are manufactured in a variety of sizes and shapes to accommodate the variety of objects that need to be packed. The table compares the area A, which is the base area. It's a what kind of shape, do you think? Rectangular carton. Oh, this is bringing in geometry. Okay, with the height H for 4 available cartons that have the same volume. Oh, wait. I got a rectangular prism. I'm talking about volume. I'm talking about base area. I'm talking about height. So I might start thinking about the equation for volume of a prism. Do you remember what that is? Base area times height. So I'm just going to write that down because it might help me. Volume equals base area. I put it in there for you. Look how easy. Look, I typed that in there for you guys yesterday. I forgot. Okay, it's right there. It wasn't in there before. So write a model that gives H as a function of A, then we take the height of the carton with the same volume, it sounds like a whole lot of words, in the table that has a base area of 75 inches. Oh my goodness. So if I have this, what letter is base area represented in this problem? What letter? A. And height is here, right? Okay, so I know that if I multiply height, or base area times height, I'm going to get my volume, aren't I? Okay, so if I multiply two things together and it equals the same number, it's direct variation, correct? So let's just see, 50 times 24. Oh, guess what? It's 1,200. Guess what? It's 1,200. 1,200. 1,200. Okay. So my ultimate goal is to write a function to get H. What is my constant of variation here? What's the constant number here? It's 1,200. Okay, it's 1,200. Okay, so I'm going to say my A is 1,200. I figured that out. And I know if I have this and I need to write a function to get H, I could represent it by the volume divided by the height, correct? Excuse me, the volume divided by the area, the A. This is my goal. I need to write a function for H. Did I figure out what the volume is, which is the constant? What is the volume? 1,200, right? Yeah? I figured out the constant is 1,200. So my height is going to be 1,200 divided by any type of area that you put in there. No matter what for these rectangular cartons. Oh, wait a minute. I did it. I wrote the function. Okay. The volume's consistent. That's my little letter A, my constant of variation. If I divide it by any area, I'm going to get the height of the carton that they're making. Now the last part I have to do is what? I had to do two things. I had to do this and I had to do this. What's the last part I had to do? Predict the height with a base area of 75. So what do I do? How do I do that? This is part one. Part two would be H equals 1,200 divided by 75. That's the base area they gave me. And H equals, what is it, 16? Okay. Okay, almost done. The variable z varies jointly with x and y. Varies jointly with x and y. Okay, so use the given values to write an equation relating x, y, and z. Then find z when x is -2 and y is 5. If z varies jointly with x and y, what's that equation going to be with just variables in it? Z equals what? A times x times y. There's always that A. In order to write, oh, I don't even have to. Yeah, I do. In order to do this, I have to solve for what? A. I got to figure out what A is going to be. So I'm going to plug in what I know. Let's see. I know z is 7 for this. X is what? Right here for this problem, right here. X is 1, and y is what? So I have 7 equals a times 2. Divide by 2. A is equal to what? Okay, so I'm going to write my joint variation equation, z equals 3.5 times xy. That's the joint variation equation for that particular set of data. Now I need to find out what z would be when x would be -2 and y would be 5. So z equals 3.5 times -2 times 5. Z would equal, is it -35? Sure, Mrs. Burgess. Okay, so that's the first one. Here's the equation, and here's the value of z when x, given the x and y. So here again, we have to find a. In order to write the equation, we have to find a. So I'm going to use this. I got to find a. They gave me that z is 24. X is 4. That's an equals. X is 4. And y is -3. I can see that a is going to be -2. Write your equation. Z equals -2 times xy. There's your equation. And then you plug in your x and your y. And hopefully you get -20. When you plug in this x and y right here.
Yeah, but don't have to be negative.
Oh, it would be positive. Never mind. Just seeing if you're awake still.